Thank you, Chris. Can you guys hear me? Good afternoon. Come on, it's after lunch. Come on, good afternoon. Thanks for joining us today. Today we're going to talk about Kubernetes and Istio at Yahoo and what we have done, what the scale we are running, and what are the challenges, some of the integration we have done. So if you look at this slide, right over here, a couple of things it says. Number one is like, this is early 2017, before we started this Kubernetes effort and Istio effort. So you can see there are n number of stack, n number of team that has their own way of tools and things they built and duplication across, right? And we try to avoid this. How can we unify this so that there's a single way for us to deploy the code, containerize the code, and there is no duplication across the team out there. How are we looking today? You can see over here, everything is containerized, right? You talk about Node, Java, even Redis, like stateful application we are running in Kubernetes today at scale, and all of them are containerized. And we use Kubernetes as an orchestration layer, and we deploy it in our on-prem cluster. So to add, you can see that Yahoo Sports, Yahoo Finance, all this critical application today is completely served off Kubernetes stack. And also adapting Kubernetes, it also gave us an option, say that in the future, if we want to take advantage of any of the public cloud offering, we can just run the application out there without making any code change or modification to the applications. So that's where we are today. Just to continue, this takes time. Okay, just to some numbers out there, right? We've been running Kubernetes for the last 2 years. We have 990 plus application, and these are our stateless application, which is serving sports.yahoo.com or finance.yahoo.com. Even yahoo.com purchase served from Kubernetes cluster. And we are distributed across 7 different data centers across the world, and we are doing 1.5 million RPS at the edge, at the ingress layer. And we also have stateful application, like all our key value store, Redis, which is HA, and as well as Redis clustering, all of those things runs in Kubernetes today. And we have an awesome operator which manages this Redis cluster in such a way that moving the shard and rebalancing the shard whenever the pod goes down and new pod getting added. So I talked about 18 production-grade cluster I had from the previous things. Out of that, 9 of them are production, remaining are from canary environment, where we do shed traffic and see how the performance and application before we roll it out, the changes to production. This is just a Grafana. I really like this dashboard. It gives a federated view of like, how are we doing across my production cluster. So in production today, as I was mentioning, we have our close to 1,000 applications. It's just one more week, we will be hitting 1K applications. And we have close to, we integrated with NetApp Trident for the storage. So we have, you can see that precision volumes. All the stats is completely available from the federated Grafana. So how does the Yahoo ecosystem look like today with Kubernetes, right? It's a very high level. So you can see those components which are in orange are those things which we have built, and remaining thing, everything we took it from the open source world and we are running. So to your left, yes, to your left, right? To your left, you can see that there is an ingress controller. The ingress controller is Apache traffic server based. This is an ingress controller. We are using Apache for various reasons because it's from Yahoo. It has lots of plugin. It's needed for our application to be served. So this is an ingress layer which is trying to do 1.5 million RPS, and that has been integrated with the Kubernetes API, where it dynamically finds this endpoint and feed it to that ingress controller. So when the request comes in, it knows where the dynamically changing pod IPs are. And you can also see to your left, there is an intranet request, right? These are the requests from either employee portal or those services which are not deployed in Kubernetes and trying to connect to a service in Kubernetes. So those requests we use Envoy. So it's Istio managed Envoy. And if you look at to your right, there's a screwdriver. A screwdriver is our CI/CD platform, and this is where we put lots of effort to template slicing so that the user can leverage without understanding the entire ecosystem of Kubernetes resource and object and everything. We'll be talking about that in upcoming slides. And you can also see something called Athenz out there. Athenz is our open source platform for service identity as well as fine-grained RBAC system. And we have built webhook in Kubernetes where it's integrated with Athenz to do service authentication, user RBAC, and service RBAC. So I just talked about Athenz. Takes a little time. So this is open source platform. It's available. If you guys want to take a look at that, you can go to this particular URL. And it's just said, it's a service identity, user identity, and fine-grained RBAC system for the dynamic infrastructure. So what's in the pod, right? Every pod which is getting deployed into our Kubernetes cluster, we have 3 default sidecars, right? It's mandate. There's no way you can get out of this. So those 3 sidecars, so in orange, are logging sidecar, which takes the log file and send it to your logging infrastructure. It could be Splunk, or it could be any other source which you have. And you have metrics sidecar. This one is to take the metrics and send it to Prometheus, or per se, we have our own on-prem monitoring solution called YAML. We can also send the data out there. And we have SIA. So what is SIA? It's Service Identity Agent. And Service Identity Agent's responsibility is to make sure that give a unique identity to every workload deployed. Right? And every pod which is deployed in our platform has a very short-lived unique identity which is provisioned through Athenz. So we'll be discussing more about that. And we have Envoy, which uses that certificate for more, it's for listening as well as a client certificate. And those services which is not using Istio service mesh in a more service to service, we don't have that Envoy. Those services which is using Envoy, you will have that Envoy as a sidecar service present. So I talked about, hey, we have 18 clusters, and we are managing this cluster. How are we building this cluster? What does it mean for us, right? And how the auth and multi-tenancy, the way we define multi-tenancy, right? And today, I call this as a soft multi-tenancy, but the reason is like, there is not, we don't build a Kubernetes cluster for every application out there, right? And we build one cluster, we try to share it with all the application out there. So we call soft multi-tenancy because they are isolated through a namespace. And to add to that, we also build a single tenancy cluster too. It's based on the use case as well as a security requirement. If our security team says that this data is very sensitive, you cannot be co-located with some other non-sensitive application, in that case, we build a dedicated cluster. If not, we just share the cluster. So better utilization, better isolation. And to continue, like once we have the soft multi-tenancy, and the next thing is like we don't make the changes. So even the cluster change of our applications, we just don't make the change and then try to push it to across all the data center at the same time. To avoid blast radius, our push process is very sequential. We do one colo, and we have metrics-based promotion, which will take that value and see how the changes are. And then if that satisfies all the requirement in terms of the latency is not high, there's no more 5xx or any other error code, only then it promotes to the next cluster. So in a very sequential way, we deploy our changes. I talked about, say, hey, we provide this soft multi-tenancy. That means like, hey, if you're a user from namespace A, you should not be able to view or access a resource from namespace B. If you say that, hey, kubectl, get, pod on the sports namespace, if it's not part of that particular namespace, you should not get to do those operations. So what we have done over here, right? Over here, you can see that every namespace in Kubernetes is mapped to an Athenz domain. So K8s, finance K8s as a namespace in Kubernetes is mapped to a finance K8s as a domain in Athenz. So to your right, you can see, to your left, right? So to my right. To your left, you see, in the Athenz, I defined a policy. What am I saying out here? If you look at the policy, right? I'm saying that, hey, allow, get, list, create. These are the bunch of action I'm allowing it for the resource. We can see that Kubernetes K8s pod exec deployment. For this resource, I'm allowing this operation for that particular role. You can see that K8s deployer as a role, right? Now that role, whoever is member of the role, can do this operation. So we can go do this fine-grained RBAC in Athenz. Now if you have a use case where, hey, I want to make sure that certain developer has very less access to my production instance. You can go ahead and create a policy which says that he can only view log file and he cannot do exec or delete or any of such operation on any of the resource in production, and he can be in a separate role called developer, and he has very minimum access. So you can define that fine-grained access with Athenz, and that's how we manage such a way that user namespace is mapped to an Athenz domain, and the responsibility of that Athenz domain, the admin is defining this policy based on his need. So I talked about user, right? In the previous slide, I was talking about the user is part of this particular role. Perfect, on time. Hopefully it's not going to reboot my laptop. Okay. So now, when the user is interacting, I was saying that every user has an identity, right? And it's an authN provisioned identity. So now I am going to interact with Kubernetes API, right? I'm going to say that, hey, kubectl get pod and the finance namespace, right? I'm going to pass my certificate. This is my user certificate. You can see the common name. It says Suresh, user.sureshv. Now, when I interact with the Kubernetes API understands, it can authenticate that request because Kubernetes API runs with its own CA as well as Athenz CA. Because he knows Athenz CA, he can authenticate this user. Now that, okay, fine, we are authenticated. Is that enough? No, anyone can be authenticated because everyone can fetch an Athenz certificate. Every employee out there can fetch an Athenz identity, Athenz certificate for themselves. The next step towards that is authorization. Right? This is where we build this webhook. Its primary responsibility is to check sure. Now that you made an operation, I've authenticated you. The next step is to whether you're authorized to do that operation. So let's look at this. Right? Suresh, as a user, is trying to get deployment and a finance namespace. We take the subject access review, and then what we do is we'll try to translate and forward to Athenz. You can see the URL at the end. You can see that it's sending to Athenz, and expecting Athenz to do the validation, check against the policy, and response back Boolean whether allowed or denied. Okay? If you are an user who's allowed to do this particular operation from the RBAC definition, the policy definition I was mentioning, then response will be allowed. If not, denied, and we respond back saying that you are denied, you're not allowed to do this operation. So now that Athenz is a very critical part of our system, like every interaction, every Kubernetes API interaction which you try to do, goes to Athenz. So we try to avoid that network hop or per se Athenz being a single point of failure for us. So we have optimized our webhook such a way that the entire Athenz policy definition, as well as role definition, as well as the member information, everything is cached locally so that the webhook can make the authorization locally without making a network hop calls. This gave us a better performance for the user, and then also like, hey, avoided Athenz being a single point of failure at point of time. Now that I talked about Kubernetes cluster, and then how the clusters are built, how our authentication model is, how is our authorization model is, how do we define tenancy and soft multi-tenancy or hard multi-tenancy, next thing we want to do is like bring in Istio to this world, right? And why are we looking Istio there? Okay, why service mesh? Like you guys all can read this. You can find the same definition from the Istio portal. Awesome feature, zero code change, right? And then lots of other advanced features such as circuit breaking. We'll need all this feature because one of the main reason is like we lift and shifted this application which has been running in the bare metal and to containerized world, right? If we have to go ahead and enable and bring this kind of feature, we need to rebuild this feature into all the languages which are out there. If you want to build a circuit breaking, right, you need to build a library for every language out there. It's like lots of duplication, right? So this was fitting our build when we saw that, okay, I can bring this particular stack. I can do lots of things in a very unified and consistent way. It can be authentication or authorization or circuit breaking, all these features instead of building libraries across many different languages there. That's our primary use case. So just to add, our service mesh layer is Istio, and I just want to make sure that I give credit to the Istio team because in the last 1.5 years, we have been working with the Istio team and teams from Google, part of early engagement program to bring Istio into Yahoo. So we've been running Istio in production for last almost as an ingress layer, for last 1.5 years. And we are now pushing changes towards where service to service also has Envoy proxy as default option. So we are not there yet. As I was talking previously, not all the pod which is in production in Kubernetes has the Envoy sidecar. It's less than 5% of the workload has that one. In 2020, what we like to get is secure communication. In a zero trust network, every service to service communication, we would like to make sure that is encrypted, right? And Istio and Envoy is the default things because we can do it in a very unified way. Authentication and authorization, I can do it in a very unified way, right? And without duplicating the piece of code across many different languages exist there. So we work with them to roll it out. We test it out. And today in production, we use Ingress as an Envoy ingress out there. 5% or less than 5% of the workload is running with Envoy sidecar. So when we talk about secure communication with Istio, you can see that this is how the flow looks like. So the service FE is going to communicate to service BE, right? The service makes HTTP call to a dependency, and the proxy in the FE layer upgrades that connection to a mutual TLS, and he makes a connection to Envoy, right? And then Envoy sends it to service BE locally in a HTTP call. Now that we said that we want to encrypt this connection, that means Envoy need a certificate, right? And this is where our CA comes into picture. What is the CA's job? I was just mentioning its primary job is to mint a certificate for every workload deployed out there, very unique and short-lived certificate. How did we do that, right? So give me a second. We build a Yahoo K8s identity provider. Its primary job is to mint a unique identity for every pod out there, and it also periodically refers that identity, right? And every certificate which is issued to the service is Athenz-based short-lived XT509 certificate. How does it work? You can see the flow out here, right? And you can see when a pod is getting created, right? When the pod is getting created and the node where the kubelet is running, when it's trying to create the pod, we have a flex volume driver. Its primary job is to create a mount and create a token ID, which is a unique token ID to the particular pod, and give that mount information to CA sidecar. And what that mount exists is an UDS socket to an identity agent process which is running locally on the node. So now that the creation process is done, the startup sequence starts. So when the CA starts up, what he's trying to do out here is like, hey, I want a certificate, right? And he's going to take that token ID, which was mounted part of the creation process, and he makes a, using the UDS, he makes a call to identity agent. An identity agent, the guy, which is a process running in the node, he takes that one and validates this is a valid token ID because he has that information because the flux volume driver created that locally as well as inside the CA, as a read-only mount inside the CA. Once he validates this is a valid token ID, he gets additional information about the pod from the kubelet API locally if everything happens within the box, right? The kubelet API responds back all the metadata information about the pod, such as his IP, his service account, all this information. Once you have the complete metadata information, you take that one, identity agent take that one, and he makes a call to Athenz. Now, Athenz got a request with the CSR asking someone to mint a certificate. So what does Athenz do? That request is also was attested with JWT. But Athenz cannot validate the certificate, the JWT, for the reason because it doesn't have the key to validate the JWT. And Athenz also need to know that who am I minting the certificate for? Is this a valid guy or some random guy somehow generating the CSR with all the pod meta information and he's sending to Athenz that Athenz is going to mint the certificate for him? It's not like that. So Athenz want to make sure that it's a valid guy. What that Athenz does is he takes that information and he sends it to our identity provider. So you can see the identity provider over there. The primary job of him is like take that information, validate the JWT, and he make sure that the pod meta information which was passed from kubelet and he validates against kubelet API. Those information are right. Once the validation is done, then he responds back to Athenz saying that he's a valid guy, he's a valid pod, he's still running in Kubernetes cluster, you can mint a certificate for him. Then Athenz mints a certificate and he passes to identity agent. And identity agent gives to CA and CA gives the certificate as a mount to Envoy. So now that Envoy has a certificate, it can use that certificate as a listening certificate as well as the client certificate. You know that Envoy has a file watch on the directory. Whenever the certificate changes, it reloads it. And these certificates are very short-lived, not more than 4 or 5 hours. So we periodically refresh it. We can also go aggressive. For now, it's like 4 to 5 hours. So once you have the certificate, that Envoy has the certificate, right? And next step is to enable authentication. What happens when you enable authentication in Istio, right? And Envoy comes with an auth filter. His primary responsibility is to make sure that he validates the incoming client certificate. Once he validates, he extracts the principal from the SPIFFE URI and sets that principal. Why is that principle important? Because once you are authenticated, the next step towards is authorization, right? So you need that principle to authorize whether the user who's connecting you or user or the service connecting to you is authorized to do the job or not. You can see the sample SPIFFE certificate out there. This is issued by Athenz, and it takes the principle from that particular URI. The next step towards is like, hey, I have to set the principal is authenticator request, whether he is allowed to do that operation. Its next step is authorization. We want to natively use the Envoy RBAC. Okay, so that's in line with the request. And it's not that we are making a request or an additional network hop or local call to authorize the request. So we want to make sure this is in line, right? And what happens when you have an inline RBAC? Like Envoy gets a request, take the principal, validate against his policy, and his response back is allowed or denied. So now that Envoy has to make the decision, that means that Envoy need that information about how the policy information, how do I make decision about it, right? So in Istio, when the RBAC is defined as integrated with Athenz, there are two custom resources get created. One is called service role, and the other one is called service role binding. And when these two resources are created, the pilot responsibility is to take this two custom resource and then push the configuration to Envoy so that Envoy can make the decision locally, right, in part of the request flow. But I was mentioning Athenz is our RBAC system. Okay, we want to define the RBAC in Athenz. We are not going to create the CR and CR service role and service role binding for everything which is manually or through a pipeline. So we built this controller. What is the primary job of this controller is to let the user define their policies in Athenz. We take the information from Athenz and create these two resources, which is custom role and custom role binding. And once you create that one, then pilots take the responsibility to push this config to Envoy, so Envoy can make a decision very locally. So what happens over here? You are a service provider. Okay, what you're trying to say is like, hey, I am going to allow get. For me, I'm an integration, OBI integration service provider. I am going to allow get operation for all my V1 user API star. Every API I'm going to allow to this particular role. You can see there is a role created called Y Finance customer care prod access and non-prod access. So whoever is member of, you can look at the role definition part of the particular guy. You can see in the to your left, you can see there your role definition, which says that Y microservice custom care prod access. So whoever is part of that particular role is authorized to make a get call or allowed to do the get call on this set of APIs. So we take this information. What you're trying to do is, if you want to allow service A, if you also want to allow service B, all you have to do is go to your Athenz UI and add the service as part of your member list. If you're done, in next few milliseconds, we take that information and then push it to we create the two CRs, and then Envoy pilot takes care from there and pushing to Envoy. So the authorization happens very, very quicker, and we are able to push this configuration very dynamically. This is high level how the controller works. It takes the information from Athenz and then just creates the two CR, and once that CRs are there, it's pilot responsibility to push the configuration so that he can make the decision very locally. So with this approach, we can see that we got Istio Kubernetes, and we are running heavily on Kubernetes, and we got Istio to do the authentication and authorization, and how we have integrated with our own CA and our own identity provider, Athenz, right? Now that we have done this work, and in 2020, we're going to make sure that all other services also running mutual TLS and encrypted, authenticated, and authorized. How did we get here, right? We have like 1,000+ application onboarded out here in last 2 years, right? That means that we have to give a very good user experience who wants to onboard to the service to gain all the benefit out of that. How does our developer experience looks like who's going to use our Kubernetes cluster and enable, bring the workload to Kubernetes and then enable mutual TLS and things. I'll let Mrunmayi talk about the developer user experience.
Thank you, Suresh. So when we embarked on our journey with Kubernetes almost 3 years ago, we were faced with the enormous challenge of having to migrate hundreds of our existing applications onto this new platform. As Suresh mentioned previously, all of these applications had their own diverse technology stacks, and they had their own independent deployment pipelines. So right from the start, we wanted to ensure that we present a simple and consistent developer experience for our developers. So some design goals that we kept in mind. The first one was simplicity. We wanted to design an easy and self-service onboarding procedure so that our developers would not need a lot of hand-holding from our side when they were onboarding their applications onto this platform. The next thing that we realized was that when you deploy an application onto Kubernetes, you need to have the knowledge of multiple Kubernetes resources, for example, like a deployment, service, ingress, etc. So this would prove to be a very steep learning curve for our developers if they had to go and learn all of those things. So we decided to build an abstraction layer which would take away some of that in-depth knowledge that was required. So we built a single simple YAML that would be able to configure all of their application configuration. And this would make it an easy and fast migration path for these developers. The next goal that we kept in mind was flexibility. So while we took care to define certain sane defaults, we also wanted our developers to be able to override those with application-specific settings. And the last design goal that we kept in mind was stability. All these tools and workflows that we were building, they were going to be something that developers interact with on a day-to-day basis. So in case we pushed out a bad change, it had the potential of impacting hundreds of our developers, and it would lead to a lot of sort of frustration with our system. So what we did right from the start was to develop a hook up comprehensive acceptance tests so that every change that we're pushing out was thoroughly tested before it actually reached our consumers. So the simple YAML interface that I mentioned, that had two main characteristics. The first was that the settings should be self-explanatory, so that just with some simple documentation, developers would be able to understand how they need to configure their application. So one example is there's a routing section. So it's very easy for them to understand that, okay, all the routing rules for my application need to be defined over there. And the second thing that we kept in mind was that they do not need to know anything about Kubernetes resources specifically. So while they could define their routing rules in the routing section, they didn't have to know anything about a Kubernetes ingress resource or an Istio virtual service. So in order to enable this, we built a standardized list of templates for every Kubernetes and Istio YAML or resource that we want to create on our cluster. Along with that, we built a proprietary templating engine. What this engine would do is it would take the set of templates, take all the default settings that we've provided, and also take the user-specified overrides, combine all of them, and create an expanded list of YAMLs. So this diagram over here, this what is in black, that kind of shows the artifact that we create. The YAMLs that we create are created on a per application environment and data center basis. So for example, if you want to create YAMLs for your production environment and you want to deploy that onto, say, a US East 1 colo, we actually create a specific set of YAMLs designed for that. Another thing that you can see here is that some of the application provided settings are there in the expanded YAML. So you can see that the app name that they specified, which is appended with the data center that they want to deploy to, as well as they told us that they want to add a logging sidecar. So we made sure that we add a Splunk container along with their application so that their pod has a Splunk sidecar running with it. Apart from these standardized Kubernetes templates that we generated, we also wanted to develop certain build templates. These build templates are based off Screwdriver, which is Yahoo's CI/CD build platform. This has also been open source, so do please go check it out. The reason for building this standard build template was that we wanted to enforce certain steps in every application's CI/CD flow. So the steps were pretty generic. So you'd want to build your code, you'd want to run unit tests, you'd then want to build a Docker image out of it, and then we'd publish it to our internal Docker registry. This would be followed by the YAML generation that I discussed previously. And then finally, we would want to deploy this entire artifact to a target Kubernetes cluster. And then we'd run the application's functional tests against it. So this would guarantee to a developer that whatever they've built locally is working as expected even when it's deployed in Kubernetes. Apart from these specific steps that we've listed here, developers can also inject their custom steps. So for example, if they want to run SonarQube as a part of their pipeline, that's something that they can very easily just inject as one of their build steps. So now I just want to go into sort of like a deep dive where I'll take an example scenario just to illustrate how simple it is for a developer at Yahoo to configure a fairly complex use case. So if I'm a developer and I want to deploy, say, a Node.js 10 application, the first thing that I'll do in my abstracted YAML is I'll specify a base image setting, which will say that I want to deploy an app which needs Node.js 10. The next thing I want to do is I want to configure the routing rules for my application. So for example, I want to make sure it routes through Istio ingress, and I want to make sure that it routes on port 443, and I also want to add a custom alias. So all of those settings can be put under the routing section that is defined there. Another thing that I want to add for my application is that I want to add an Istio sidecar, and I want Istio to enforce two things for me. One is to add strict mutual TLS, and the other is to make sure that every outgoing call from my application is restricted to a whitelisted set of endpoints. So all of that configuration for my Istio sidecar would be, as you can see in the sidecar's Istio section. Here I can also specify certain like resources that I need for my Envoy sidecar, like memory or CPU. So as you can see that all those settings that I mentioned, which would have resulted in multiple Kubernetes or Istio YAMLs, can be abstracted and described very simply in this one YAML that you can see here on screen. Of course, behind the scenes, we do go ahead and create all the YAMLs that are required. So you'll see your Kubernetes deployment, you'll see your Istio policy, virtual service, gateway. Everything that you need to make that configuration a reality is actually being created behind the scenes. But developers didn't need to know any of it, so they can reap the benefits of all these features without getting too deep into Kubernetes or Istio. Apart from all the features that Suresh and I have mentioned so far, there's a lot of other cool stuff that we have on our cluster that developers can use. For example, rate limiting, fault injection, distributed tracing, traffic shifting, as well as securing the egress for your application. Just one more thing that I want to call out is all of the tools that Suresh mentioned previously, all our Athenz integrations, like for example, the Athenz Istio RBAC controller, they've all been open sourced. And aside from the ones that we've mentioned, we also have a couple more in the field of policy and security, for example, security benchmarking. So all of these have been open sourced, and if any of you is like a Kubernetes cluster operator, they're fairly generic use cases, so definitely do go check them out. And if you have any features or any issues that you see with it, we're very open to any contributions. That's it for me. I'll pass it to Suresh to conclude.
Thanks, Mrunmayi. I'm going to conclude, right? We're running out of time, right? So we got this Kubernetes and Istio stack today, and we are running over here, right? It helped us to modernize and standardize our stack. And very importantly, other aspect is like, it helped our product velocity and improved our developer productivity. Finally, it also improved our application security. It's enhanced it. And one other thing also I want to call out is like our cluster utilization has grown up because we've been packing different set of workload into the same cluster, so the utilization is very, very, very high. With all the benefit which we have out there and all the critical applications such as Yahoo Sports, Yahoo Finance, and Yahoo Homepage, this creates millions of RPS, is completely sort of Kubernetes stack, which we are very, very, very proud of. And again, we love Kubernetes. Thank you. And yes, we are hiring, and if you want to join me in the journey of pushing towards the containerization and then bringing other set of application out here and in the journey of Istio, Kubernetes, OPA, please join me, and you can reach out to me in this mail ID. And if you have more questions, we have a booth at E8. Please come over there. I'll be happy to answer any questions and any hiring questions too. Thank you.